everyone, I think you are doing good. In this video we are going to discuss about linear search. Linear search एक टेक्निक है by which we can search any item whether it is present in the array or not. मान लीजिए आपके पास एक array है, एक integer array है suppose, तो मैं इसको fill कर देता हूँ. Suppose I have 51, 76, 12, 11, 2 and 1. तो आप suppose आपको एक मैं नंबर देता हूं, आपको ढूंढ के बोलना होगा वो इस एरे में है कि नहीं. हाउ वी विल डू दैट? वी विल डिस्कस द एल्गोरिथम, वी विल आल्सो डिस्कस द ड्राई रन एंड देन वी विल डिस्कस हाउ वी आर इंप्लीमेंटिंग दैट इन द कोड. उससे पहले एरे क्या है? एरे एक होमोजीनियस डेटा टाइप का कलेक्शन है. यू कैन से दैट ऑल द डेटा टाइप्स ऑफ द इंडिविजुअल सेल्स ऑफ दिस एरे इज सेम, इसलिए इसको बोलते हैं होमोजीनियस डेटा टाइप. होमोजीनियस डेटा टाइप मींस सेम जीन मींस सेम टाइप, डेटा टाइप इज सेम, सो ऑल आर इंटीजर्स. नाउ आई हैव एन आइटम, ऑब्वियसली ये इंटीजर आइटम होगा. ये सब हम लोग कंसोल इनपुट लेंगे. तो आप कैसे इसको ढूंढेंगे? तो एक इजी, सबसे इजी उपाय जो है, सपोज आपको मैंने एक शेल्फ में बहुत सारे किताब दे दिया है. तो इन द शेल्फ देयर आर लॉट्स ऑफ बुक्स. मैं आपको बोला कि मुझको लेटेस्ट सी का एक बुक का नाम है ये, तो उसको ढूंढ के दो मुझे. तो आप क्या करेंगे? शेल्फ के हर बुक को आप चेक करेंगे, ये वाला सी का बुक है, ये वाला है, ये वाला, आप चेक करते जाएंगे. अगर आपको मिल जाता है दैट मीन्स यू हैव फाउंड दैट, यू विल से ये यहाँ पर था, ये लीजिए. तो उसके बाद वाली चीजों को आप नहीं ढूंढेंगे ना, तो ये स्टॉप हो जाएगा वहां प्रोसेस. अगर आपको नहीं मिलता है तो आप इसको चेक करेंगे, इससे साथ चेक करेंगे एंड देन यू विल गो टिल द एंड. यू विल चेक इंडिविजुअली, लीनियरली, राइट. तो हम एक आइटम को जो हमको इनपुट दिया गया है, जिस आइटम को हमको सर्च करना, वो आई वुड सर्च दैट लीनियरली थ्रू आउट द एरे. लीनियरली मतलब डायरेक्ट कॉम्बिनेशन, वेदर आइटम इज इक्वल्स टू दैट पर्टिकुलर एलिमेंट ऑफ द एरे और नॉट. ये आई है इंडेक्स, ये जो इंडेक्स मैंने बोला है ना, एरे का इंडेक्स स्टार्ट होता है 0 से और 0 से लेंथ -1 तक चलता है ना. ये साइज है 6, तो एरे का जो लेंथ है, लेंथ पैरामीटर कितना है? 6. तो इंडेक्स चलता है लेंथ -1 से. ये वाला बहुत ही फंडामेंटल कॉन्सेप्ट है, बहुत स्टूडेंट्स गलती करते हैं, तो ये वाला चीज़ आपको ध्यान में रखना होगा. तो ये जो इंडेक्स है, मैं अगर इंडेक्स को स्पेसिफाई करता हूँ तो एक एक एलिमेंट के साथ ये चेकिंग होगा ना. तो ये वाला हमारा प्राइम कंडीशन है दैट वी विल एम्ब्रेस दैट इनसाइड फॉर लूप. सो ये हार्ट ऑफ दी प्रोग्राम है. तो आपको लीनियरली चेक करना है, 17 इसके साथ इक्वल है, नहीं है, फिर इसके साथ चेक करेंगे. अगर नहीं होता है तो फिर नेक्स्ट एलिमेंट में जाएंगे. अगर हमको मिल जाता है, ये तो 2 आउटकम देगा ना, येस और नो, राइट. ये हमको देगा येस और नो. अगर हमको मिल जाता है देन वेल एंड गुड, वी वुड से दैट हमको मिल गया है, the program ends here. But अगर suppose हमको नहीं मिलता है तो we will propagate to the next step. We will check 17 with 76 means in the next position. Then अगर ये मिल जाता है तो ठीक है, नहीं मिलता है then next element के साथ चेक करो, नहीं मिलता है तो next element के साथ चेक करो. इस तरह से हर एलिमेंट के साथ लिनियरली हम लोग चेक कर रहे हैं कि इसीलिए इसको लिनियर सर्च बोलते हैं. As we are searching we are evaluating the equality expression. equality ये है equality operator, equals to operator है relational operator. ये दो ऑपरेंड्स के बीच में ऑपरेट करके ये बोलता है कि whether it's equal or not. equality को चेक करता है, returns true or false. तो हम लोग क्या कर रहे हैं ना, we are searching the item in the array linearly. We are comparing all the individual elements linearly with the item to be searched. अगर मिल जाए तो well and good, we would say it's found. If it's not found till the end of the array, हमको इटरेट करके देख लिया हम लोगों ने कि नहीं मिला है, तो क्या बोल देंगे? इट्स नॉट फाउंड. तो ये जो प्रोसेस है ना, वेदर इट्स फाउंड और नॉट, उसके लिए हम लोग को एक फ्लैग वेरिएबल यूज करना होगा. फ्लैग मानो तो ये है वो फ्लैग, ठीक है. अगर मिल गया तो हम बोल देंगे हाँ मिल गया है, अगर नहीं मिला फ्लैग डाउन, वी आर नॉट सक्सेसफुल. तो इसी तरह से हम एक वेरिएबल लेंगे जिसमें वी कैन स्टोर ट्रू और फॉल्स. अगर मिल गया तो हम लोग ट्रू सेट कर देंगे और लूप को बंद कर देंगे विद द हेल्प ऑफ ब्रेक स्टेटमेंट. अगर नहीं मिलता है तो उसमें फॉल्स ही रहेगा, तो हम लोग बोल देंगे कि वी हैव नॉट फाउंड दैट. अगर मिल जाता है तो ठीक है, तो वो ट्रू हो जाएगा एंड वी वुड स्टॉप द लूप यूजिंग द ब्रेक स्टेटमेंट। अगर नहीं मिलता है तो लास्ट में देख लेंगे वो फॉल्स है तो ठीक है, इट्स फॉल्स एंड वी हैव नॉट फाउंड दैट, वी वुड प्रिंट दैट एरर मैसेज। हम एक मैसेज दे देंगे यूजर को कि वो नहीं मिला है। तो फ्लैग वेरिएबल बुलियन भी पकड़ सकते हैं आप लोग, बुलियन है ये, और कोई कोई इंटीजर भी लेता है, 0 या 1 पॉइंट करके बोल देगा। अगर इंट लेते हैं तो इंटीजर फ्लैग भी हो सकता है, बुलियन फ्लैग भी हो सकता है। तो ये था हमारा मेन जो एल्गोरिदम था। मैं और एक बार जिस्ट कर देता हूँ कि इस आइटम जो है, जो यूजर हमको इनपुट देगा और हमको चेक करना है इंडिविजुअली विथ ऑल द एलिमेंट्स ऑफ द एरे, इफ इट्स फाउंड we would print the message that it has been found, and we can also specify the position where it's found, and if it's not found at the end of the process we would say that we have not found. This can only be verified, ये हम तभी बोल सकते हैं जब पूरे एरे के साथ कंपेयर करके हम लोग लास्ट तक चेक कर लिए, उसके बाद हम लोग बोल सकते हैं कि वी हैव फाउंड और नॉट फाउंड, राइट। तो ये था हमारा अप्रोच और इसको हम कोड में इंप्लीमेंट करके देखेंगे इसके बाद। Hello guys, now we are going to look on the code implementation of linear search in Java. So I have written a main method here. This is the public static void main under the class linear search, and I have used the buffer reader class to take the console input. You can see that we have initialized the array. ARR is an integer type array variable with size 10 and the data type is int. So just as I told you in the last lecture that array is a homogeneous collection of data type. You can store a same type of data in it. So it's a homogeneous collection of data, right? So the next loop that you are seeing from line number 11 to line number 15 is basically meant for taking the console input. Console input means you are taking the user input, means the user is giving the input in the terminal window or in the console where we would run the program. Now you can see that I have generated the index loop. As index starts from 0 and ends to array.length minus 1. So I have started the loop from 0, and the condition of the for loop is it would be executing till it reaches array.length minus 1. Note that I have used smaller than. Smaller than means just one value less than the one that we have at the right side or the right operand. This is an operator, right? This is a relational operator. This is one operand and this is another operand. Operands are those elements on which operators work upon. So the right hand side operand is the length of the array. So smaller than array.length means one less than the array dot length, means the index will run up to length minus 1. So we know that array starts from 0 and the length minus 1 is the last index of the array. Now how the loop variable would increase, that is I would be incrementing by 1. I plus plus means I equals to I plus 1. In this context it is same. But mind that post increment and pre increment behaves differently when they are used in expressions. That we would talk about in a later video. Now here I have given that print statement where the user would be able to see a prompt that to enter a number, and then we would enter that number and integer.parseInt. This is a method of the wrapper class integer which converts the string whatever we pass as a parameter. So here the parameter is r.readline. R is the object of the bufferedReader class and readline is the method written inside the bufferedReader class. Now, this readline method has the capability to read a line as a string from the console window. I repeat, readline is that method inside the buffered reader class which has the capability to read a line from the console window or the terminal window as a string. So that string, whatever is returned from our .readline, is being converted into an integer via this parseInt method, and that we are assigning with the help of a assignment operator. Assignment operator, what it does, it assigns the right hand operand value in the left hand variable. Here array element at ith index would be allocated by this value. So this value would be stored in the ith index of the array. So this continues for the whole length of the array. So we are filling the whole array with our user input. Next we are taking the input, the item that the user wants to search, and now we are going to implement the linear search algorithm.
What happens in linear search algorithm, as I demonstrated in the last lecture? If you haven't seen that, please look to the playlist that is just beside this video that is being played, and you can watch how the algorithm looks in my demonstration in the board work that I have shown. So this loop is responsible for again generating the index loop up to the length minus 1, and we are checking whether the element at the ith index is equals to that item or not, the item that we are instructed to search. So we are just giving this equality expression, and if it gets executed, if it executes, then we know that the array consists, or our item is present in the array. If this is true, this if condition is true, that means we have found that, right? It's found. So we are considering, we are storing one in flag. One means true, zero means false. So I have used here a integer flag. You can also use a boolean flag. Okay, no issues. You can use a boolean flag with a variable as flag name and boolean data type, and here instead of zero, just you have to write as false, and here instead of one, you have to give true, and here you have to give false. So if we have found the item in the array, then what we are doing, the first task is to put the flag up and say that we have found that. And then we are printing the message that we have found at this position. Note that I have added 1 with the index because the position is the conventional position, and the position is always 1 more than the index because index starts from 0, right? So the position, the first element is at 0 index. So position is always already plus 1, right? 1 first position, 1 its index is 0. So index plus 1 is the position. That's why we have written I plus 1. Then I have used the jumping statement, that is the break statement. Break statement jumps the control out of the loop. So if we have found the item, then no need to check again and the loop needs to be terminated, right? So this break statement will terminate the loop and the control would jump to line number 31 now, because the loop has terminated and we would not execute. Now, consider that if item was not present in the array, then this expression would never return true, right? It would always return false because no element in the array matches with the item that the user wants us to search. So it would never give us true. Now, if it never gives us true, then this code block will not execute. If this never executes, then after complete execution of the loop, when the loop executes completely from 0 to array dot length minus 1, after that the value of flag would be 0 only, right? It has been declared here, initialized with 0. If it never executes, then this line would never execute. If this line never executes, then the flag variable would be always storing the value 0. So we would get 0 only, and if it's 0, we would say not found. So see how this simple integer variable is helping us to determine the state whether we have found or we have not found. This is the beauty of using flag variables. So here is the implementation of the linear search algorithm, and now we would execute this program. Now let me run this main method, and it will execute in the terminal window or the console window. This is the console command prompt. So see, this particular Java class is being executed. Now we have to give the input, the numbers in the array. We are giving the numbers in the array. There are 10 elements, so I have to give 10 numbers, right? So I am giving 10 numbers randomly. I am giving 10 numbers. You can see that. Let me fill the array. Now the program is asking to enter the item that we need to search. Suppose I want to check whether 45 is present or not. So let me see. So 45 is found at position 9. So yes, this was the 10th element. This is the ninth element. So we have found that. Now let's check with a number that is not present in the array. So in that case, we should get not found, right? So let's check that also. We are filling the array with the numbers, random numbers. Now suppose I have given 555, which is not present in the array. So our output is not found. So here we are with the code, and it's being tested now. So this is the implementation of linear search. Now next we would talk about binary search in the next video. And if you are new to this channel, subscribe that. We would bring forward latest videos and you would get notified. See you in the next video. Thanks for watching.